Hello and welcome to Dr. T's Algebra 2. In this video I will demonstrate how to use the quadratic formula to come up with unreal or complex solutions. And I will also look at the discriminant and what that tells us about the solutions. So we've got a quadratic in standard form here, 3x squared minus 4x plus 7. And we're just going to put that into the quadratic formula. We got b plus or minus the square root of b squared minus 4ac all over 2a, negative b squared. Negative b at the beginning. And so this part here is the discriminant under the square root. If that is positive, then we have two real roots. If it's 0, there's one real root. If it's negative, there are no real roots, and there are two complex solutions. If there's one complex solution, there's always another. There are always two complex solutions. So we'll just start substituting values in here. Negative 4 is 4. That's our negative b at the beginning. Plus or minus the square root of b squared, which is 16, negative 4 squared. Minus 4 times 3 times 7. 7 times 3 is 21. 21 times 4 is 84. So 16 minus 84. All divided by 2a, 2 times 3, which is 6. And from here we'll just go step by step and simplify, solve, simplify. So this is 4 plus or minus the square root of 16 minus 84. Well, 84 minus 16 is 78, 68. We'll just turn that negative, negative 68. Still divided by 6. Continuing along, now I can split up the two parts of our fraction. If I've got two parts in the numerator and only one common denominator between those two parts, I've got addition and subtraction here, means I can split this up into two fractions. And so I have 4 over 6 plus or minus. Now this negative sign here is an impossibility. Right, because we can't square a number and get a negative number. A negative number squared is a positive number, so this is an impossibility. So what mathematicians found out is that we can just call that I. I stands for imaginary, and if you want to go down the rabbit hole of Kurt Gödel and others who went mad thinking about mathematics, well then I encourage you to ponder what that possibly could mean, that there's an imaginary number. But actually, my advice is just don't think too hard about it. That I right there, this I, just tells us that was a negative number inside the square root. Pull it out. And so now we got the square root of 68 multiplied by I. And we can start to simplify now. So 4 over 6 has a common factor. We got common factors in the numerator and the denominator of 2, so that's 2/3. And that's still plus or minus. And we can pull out a 4 from 68. 4 times 17. So when we have square roots here, we still got I. We have square roots. We can simplify, or we can break this up into parts. The square root of 68 is in fact the square root of 4 times the square root of 17. And that's all over 6. And now 4 is a perfect square. And so we can take a 2 out of that 68. We're going to get 2/3 plus or minus 2i root 17. 17 is a prime number, so we can't simplify that any further. That's all over 6. And then finally, 2/3 plus or minus. Get rid of the common factor of 2 between 2 and 6. I root 17 over 3. And so we see that there are two complex solutions. A complex number is a real number and an imaginary number. And when we use the quadratic formula to find that complex number, there will always be this plus minus in the middle. If we had a negative on the bottom, we can just get rid of that automatically because this plus minus in the middle takes care of that. So there are always two complex numbers when this discriminant is negative. Okay, this has been Dr. T's Algebra 2. In the next lesson, I'll talk more about complex numbers. Thank you.